Okay, so what's up everyone, my name's Alex and this is going to be another video to do with computing. And for this video I'm just going to be explaining how you convert binary digits into hexadecimal digits. Now basically what hexadecimal is just another form of, showcasing digits and all that. It's also used in color referencing, like RGB. So you'll have RGB sequences where there's 3 different numbers up to 255, and then with hexadecimal you'll have things like, it might be something like 15, 8, 4, 12 or something like that, and then you might have B and F and all that. So basically what I'm going to do is I'm just going to explain briefly what hexadecimal is, and from there I'll just show you some examples. So with the hexadecimal, it's base 16, which means there's 16 digits available, and that is from 0 to 15. And normally they don't include the zeros, but for hexadecimal you do. So it's 0 to 15, and from the first 0, including 0 to 9, it's equal to the first 9 digits. You know what I mean? So 0 is equal to 0, 1 is equal to 1, 2 is equal to 2, etc. But as soon as it gets to 10 to 15, it's equal to A. So 10 is equal to A, 11 is equal to B, 12 is equal to C, D is equal to 13, E is equal to 14, and F is equal to 15. And when you're trying to convert binary to these, what you do is it should be like a long sequence. So I'll have a sequence of 16 binary digits. So I'll do 1010, 1110, 0110, and then what can I have? 1000. So what we have here is, or should you actually, yeah, I'll have 100. So what we have is, we'll have a sequence of 16 binary digits, but we separate them into 4. So it's 4. So there should be 4 sequences of 4 binary digits. And what we do is, since this is the power of 0, this is the power of 1, this is the power of 2, and this is the power of 3, we know that the numbers below it, oh god, this is going to be 8, this is going to be 4, this is going to be 2, and this is going to be 1. So we're just going to put this in the table. Insert table. Hope so. Oh, there we go. Oh god, no. So basically, 1, power of 0, power of 1, power of 2, power of 3. Now what we do is we add up the values which are a 1. So these values are 8 and 2. So we add up 8 and 2, which equals 10. So we know that the first sequence is going to be 10, and since 10 in hexadecimal is equal to A, the first sequence is going to be A. So the first sequence letter is going to be A. So then we do the same with 1110, so it's 8 plus 4 plus 2, which is 14, which is E in hexadecimal. So you have A, E, I'll leave the comma, so get rid of that one. And then we have 0, 1, 1, 0. So looking from the right, 1 isn't a 1, 2 is a 1, and 4 is a 1, but 8 isn't a 1. So all we do is add up 4 and 2, which is 6. So we just put 6 there and get rid of that. And then for the last one, we know since all of these are 0, and this is equal to 8 in the power section, so this is just 8. So it's just AE6, 8. Oh god, now I need to rewrite all that and show you to confirm it. 1 minute, I'll pause it. Okay, so that was embarrassing. So now we know that since we converted all of these binary sequences to individual digits, we know that the hexadecimal value for these 16 binary digits is AE68. And I'll go into Google and just confirm that. And so as you can see on the website Maths is Fun, with the binary to decimal, the hexadecimal converter, you can see that the binary that I've typed in, 1010, 1110, 0110, 1000, is equal to AE68, which is what we've got. So I'll move that again. So that's just one example. I'll do another example. So we'll have 1110. What else can I have? 00011, and then we'll have 1011, and then 0000100. So now we look at it again. We'll start from the left. Now since flipping heck, we see that 8, 4 and 2 are all 1. We add these together. We don't add the 1. So it's 8 plus 4 plus 2, which is 8 plus 4 plus 2, which is 14. And in hexadecimal, that's E. So we know the first letter, or first part of our sequence, is going to be E. And do the same for the second. So it's that. So it's 0, 0, 1, 1. So we'd look at the only ones we add are the ones that are 1. So we add 2 and 1. So that's 3. So we know that 3 stays the same. So the sequence goes E, 3, like the gaming convention. And then for the next part, we do 1, 0, 1, 1. So we know that 8 is 1, 2 is 1, and 1 is 1. So we add 8 and 2 and 1, which is 11. And 11 in hexadecimal is B. So we have E3, B. And then the last sequence is 0, 1, 0, 0. And then so we look at 1. This 1 isn't 1, so we don't add it. 2 isn't 1, so we don't add it. But 4 is 1, so we do add it. And 8 is 0, so we don't add it. So we have 4, which is 4. Since with hexadecimal, it goes from 0 to 9, and that just equals the normal, digits. But from 10 to 15 onwards, it equals, from the start of the alphabet, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So we're going to Google again and type that in. So 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0, 1, 0, 0. So as you can see, I've just typed in that binary on the Maths is Funny's website. I would recommend it because it is really quick and it tells you between binary decimal and hexadecimal. So as you can see, the binary that I've just typed in is exactly the same that I've just worked on, and that is equal to the hexadecimal that I've worked out as well. So that's correct. So all you do is you should get a sequence of 16 binary digits, convert it into 4 from the left, just convert it into 4 chopped up, and then add them all together, the binary digits which have a value of 1 in the specific power range. And then if it's over 10, it'll be in the alphabet range. If it's less than 10, it'll be in the number range. I'll try and explain again how the powers work. So I'll just do for 4 digits. I'll have 0, 0, 0, 1. What we have where 1 is, it's the power of 0. So that means that it starts, the power of 0 is 1. So that's going to be 1. And then we have the power of 1, which is 2. And then we have the power of 3, which is 4. Then with the power, power of 0, power of 1, power of 2, oh god. So, sorry, we have power of 0, power of 1, power of 2, and power of 3. Now all it is, the powers is something, you times it by itself 3 times. So 2 times itself once is 2. 2 times itself twice is 4. 2 times itself 3 times is 8. So 2 times 2 is 4, and 4 times 2 is 8. And then it keeps on going. And then so you have this one, the 4th power I believe, which will be equal to 16. Flipping heck. Which will be equal to 16, which is the power of 4, is it? So you have 2 times 2, which is 4, 4 times 2, which is 8, and then 8 times 2, which is 16, and then it keeps on going on and on, so it's the power of 2. And binary is called the base 2 because it's only 2 digits available to use, and also because you times it by that amount, so it's the power of 2. So I'll move that again. I'm hoping that's cleared it up a bit, because it's a bit difficult to explain, I suppose, because I'm not the most mathematical person out there. But yeah, hopefully you've learned something. I have explained, I've done 2 examples of hexadecimal conversion, and hopefully you've learned something. If not, just put in the comments what I can do better. And yeah, thanks for watching. See ya, bye.